Hello, good afternoon. Welcome to the last webinar of our introduction to Python. Today we have the topic iterations, and we'll look at something. We'll expand what we did on arrays last time, and that means we look at nested arrays. Just one level deeper than what we did before, but that will prepare us to have arrays of the size that we will handle in the data science and machine learning part. And once we have that, we will iterate through it. So we'll learn how iteration works in Python. And I will put specific emphasis on doing it the Python way. And finally, we'll do the same thing again, but with Numpy arrays, because that's how we work in machine learning. So for the first part, screen is sharing. If I refer to something on the screen that you can't see, please unmute yourself and shout. Sometimes I noticed in a different class yesterday that pictures were not visible for some reason. And if somebody just interferes, then we'll be able to sort it out on the spot. Right, so I have showing on my screen my Jupyter notebook. Of course, let's do a new one. What's the first thing is rename that. What do? We start with nested arrays. Nested arrays, so I rename that, make a little bit of space. And the reason we want to look at nested arrays is because just a long line of numbers, even if it's a very long line of numbers, is not how we work in data science. We work with matrices and we have rows and columns, and that's where we are heading to. So let me just start by reminding ourselves what we did before. So we created, for example, in arrays lists, and we called the list we created it using square brackets. And once we had the square brackets, we filled it with items 1, 2, 3, and so on. And then when we refer to my list, just by name, we can see that this is the result. Now let's create, based on this example, a nested list. So a nested list is now defined as my nested list, so just call it my nested list. It's now defined as an array that has multiple levels of entries. So of course, the outermost level is, as we did before, is a list. And in the above list, if you remember, how many items were there? 1, 2, 3 numbers. So that's 3 items. So every item can be an integer, as we have it here, but every item can be a list. It's a nice thing about Python that everything sort of can be self-referentially expanded. So what we can do is we can put in 3 lists by square brackets into the list. Then we have a list of lists. So let's fill that with some numbers. 1, 2, the same item separated by comma, 3, 4, and 5, 6. So now we have a nested array or a nested list. Special case is a list. And if I just copy and paste this name here, then we can see, yeah, it's just how I input it, but we have the 2 sets of square brackets, the outermost and the 3 inner pairs, and this will help us group the list. So let's have a check. We learned the function len to determine how many items are there. Not len, but len, L-E-N, highlighted in green now. And then we would say my nested list. So what do you expect? Is it we have 6 numbers grouped in 3 pairs in one list. So what answer do we get? We get 3. So if you like, 3 pairs, which is 3 items on the first level of that list. So we work with nested lists very much like we worked with lists in the first place. We can use my nested list and, for example, append to it something. And having already a couple of lists in there, we can append another list. So what do we have? 5, 6 we have. We can append a list with 7, 8, and then my nested list, if we append something, will just get longer, right? So there's a new pair at the end. Of course, we can also add things that are not lists of 2 numbers, right? If you now think it always has to be 2 integers, this is not the case. Let's make another example that's based on one of the questions that came around. Let's insert something. So what we want to do is we want to have my nested list, and we want to use, what do we have here? Insert, right? We want to insert a new item into that list. So insert works by calling the position where you want something inserted. So if we want something in that list, if we want something, say, before the 7, 8 pair, so we want something after 5, 6 and before the 7, 8, where would it go? So it would go after 5 and 6, and that's the position 0, 1, 2, 3, right? Now 7, 8 is in the position 3, index 3, Python counting. And if we want first to have something new there and then followed by 7, 8, then we need to specify index 3 because that's where it should go. So let's do that. Let's also learn a little bit or practice a little bit. Good programming practice is namely to not use that item 3 that we sort of have now visually figured out where we want to have it. We don't put in those specific numbers in the call to insert, but we define that as a parameter. So let's call this the new item index, the index of the new item. And we want to have that in position 3. So let's give it a name. Right, it's new item index. So we know the new item that we want to add has the index 3. And then we can use that number in order to insert in that location. So how do we do that? Now with my nested list, we use insert. And then we need to specify where is it going to go. So we can do new item index. So we define that number 3. So imagine there's the number 3 in there. And then you need to, of course, say what you want to have in this position. And we can add an integer if we like, but we can also add things that are not lists like a tuple. And we can also add something that is not numbers like strings. So let's make some nonsense here, A, B, C, D, E, F. So it's now a pair, a couple of strings, 2 strings, and we can insert them into that list and then check if my nested list, what happens. And now we have a longer list that has expanded, and we have in the position where we wanted it, position 3 now, we have put a pair, a tuple of strings. Right? So that's how things can go. Now, indexing, first part of indexing, how do we index this? My nested list, of course, you can start by experimenting or just guessing. You remember list, we just gave the index in square brackets. So let's see what happens if I say 0. So the item at index 0 is the list with 2 members. So that's why nested list. So now within the list, a single item is itself a list. And if we replace that, if I just copy that code, and if you replace that by the new item index, say what is the thing that is now at the position new item index, then of course you can guess this is the tuple of strings, that the one that we just included at news item index. So it's then easy to refer to it. You know where you put it because you kept that number 3 as a parameter here called new item index. and you can refer to it easily. And of course, you can use the same thing, addressing my nested list by pop. You can remove it. If you haven't learned it, check those things. Pop is to remove by referring to index. I think I mentioned it briefly 2 weeks ago. And then you just say pop new item index, which is where the strings, if you think these strings here are very odd things, actually we want to see the numbers in the ascending order, then you can use pop, refer to that index where the whole tuple is, so everything contained in that tuple, and then we want to see the result. And that's what we have now. So we end up with just a list of lists. Every list is a pair with 2 integers in this order. So now you know how to access the pairs within a list. What if you want to now access the 1 and 2 individually? So a member of that list that is in that item that we have here, and that's done by double indexing. Let's have a look at double indexing, just a final example. My nested list 0 is the list with 2 numbers. And if we now want to access one of the numbers individually, so we know 0, and then we give a second pair of square brackets, so the second index, so to speak, and then we say 0, and 0 will be the first number. And if we change that 0 to 1, of course, we'll get the second number. So how do you access the 8? Number 8, if you want to know the number 8, it's in the last item of that list. So you can say -1. And within that item is in index 0, position 0. So let's try this one here. And indeed, my list -1 gives you number 8, which is the last number in that list, as you can see above here. So that was just to get you ready sort of for the matrix that we use in data science, where we have rows and columns. It's not called like this here, but this is essentially what we have in a nested list with 1 level of nesting. And we will later do the same thing with Numpy arrays, where we don't use this double indexing with 2 pairs, but we will see that in Numpy arrays we'll use a single pair of square brackets to index every item in a 2-dimensional matrix. Right, that was our first part. And let's have a look at how to iterate and work on each item in one of these collections of numbers. So the first thing we want to do is start very simply, just a simple list. So create a list, my list, and then in square brackets 1, 22, 3, 3, 3, 4, 4, 4, 4, 5, 5, 5, 5, 4, 4, 4s and 5, 5s. Okay, something like this, just an arbitrary list here that I create. And now I want to operate on each of these items on the list. But the idea behind iteration is, what if you do the same thing with different members of that array? So doing the same thing means you're immediately thinking iterate through it. Iteration is repeat a process, doing the same thing, just having different numbers to work on. And we'll do it in a sort of 2 or 3-step fashion. So the first is, how do we access each of these numbers in that list? So if I'm sort of very naively thinking of what we just did before, or 2 weeks ago when we introduced arrays, we can say, well, you can find each member of that list by indexing it, right? So you know the number 1 stands at index 0, 22 stands at index 1, and so on. So if you knew those indices, you could just go through indices and access the list at that index. Okay, so let's do that. So we say for index in, contained in is in green is an internal, it's a logical operation, check whether it's a member of that list. And the indices, well, we don't have the indices, we can create a list with the indices. So that's why I'm saying just very simple. The first is 0, then 1, 2, 3, 4, right? We have 5 numbers, so we have indices 0, 1, 2, 3, 4. And the way the for loop works, if you want to do for each of these indices, if you want to do the same thing with whatever number stands in that place, then you do for index in that list, colon, and now you will immediately remember conditional statements, new line, indentation, and then whatever you want to do, say print. Well, let's do first naively the simple thing. We have created a variable called index, right? We now go through that list of indices one by one, and then we have first index 0, then 1, 2, 3, 4. So index will be each of these variable names, and then we can just print it. So let's just do that simple thing. What is the result of this? So for index in that array, print the index, and then make a new line, print the next, and so on. We'll just give you the indices. So as you can see, you get this column 0, 1, 2, 3, 4. This is just giving you back what you input. So of course, now we can use that code, just copy and paste it, use that code. And instead of index, I print the number which is at that index. How do I access the number? Well, it's contained in a list called my list. And if you index the items in that list, you can use index, just the variable that we had, right? So for index 0, you'll get my list 0, which is the 1. And for index 1, you'll get the second, which is the 22. Hopefully, or we'll see, we need to check. But here is the code for index in that list of indices, colon, new line, indent, print the number which is at that index in an array called my list. And then you get them one above the other, or one below the other. So I have this nice pyramid here of those 5 numbers. And that's nice, it works, but that's not the way we do it. No, no, no. So now you saw it, forget it. Now we do it the Pythonic way. The Python way of doing it is a little bit different. So if you have learned it like this, other languages like MATLAB do it sort of in this way. You get those indices and then you call indices. No more. Now it's the Python way of referring to it. So let's do it this way. Let's see what we can do with that list. For, we use a for loop, the same as we did before. And we call it now not for index, we go through the contents of the list. For number, whatever is in there, now in this case it's numbers. For number in my list. And that's it. This will just go into that array, which is a list, and get you the first number, the second number, the third, and the fourth, and the fifth. Okay, so let's check, print, like we did before, print, it's called number. And there's a line that was, and we'll get it out immediately. So this is the way to do it. You run through arrays using for item in that array. So you don't use the indices, you go through the items in the array. And once you have them, of course, then now you know how to do it. Now you can do anything. And the reason why we're using a for loop is not to see the numbers, you can see them more easily, but to do something with them. I don't know, like squaring them or using the square root or whatever. And you can, the square to the power of 2 or the square root to the power of 1 over 2. Whatever you want to do with that number, you can do it, right? So just do it. So now we have 1, and this 1 squared is 1, and 22, and 22 squared is 484, and so on. And so that's how we do it. Now, a comment, of course. Now, of course, in data science, of course, very often we do want to have the index. right? Above, we worked with the index. We sort of created this list of indices and went through it. And we don't need it. We can operate, we can get the numbers and the squares and whatever is like this. We have it now, but sometimes you do need the index. You do need to know, well, if that number is in this index, maybe I can go to another array which has the same length, but which has different information, pieces of information related to that number. And then, of course, you want to have the index of the number in order to access that other item which belongs to that number. So yes, there is a way, of course, an easy way in Python to get the index, but it's not the way we did it above to create the index. You extract the index. You can do it during the for loop. I'll show you how. Before I do that, that needs a little bit of a distraction here. We do something called, it's a topic that's called unpacking. So I highlight it here. So you know, now we talk about unpacking. And so let's have a look. It's unrelated, but it has to do with how to get the numbers out of an array. So if I create an array, which I call my tuple, now different just for example, and it contains 12 and 13, two numbers, right? A pair of numbers called my tuple, and there is my tuple, and it's 12, 13. You can extract those numbers from that array just by assigning it to different variables. So if I call the first number 1, number sub 1, and the second number sub 2, so the first and the second number, then I can just extract them from the tuple by referring to the array. It's not my list, it's my tuple. And if we want to see that, print, we say print number 1, and we print number 2, right? So we extract the two numbers and then we print them. And there we have them. The first variable is just that one number 12, and the second variable is just that number 13. So this is then this first line of that code is the unpacking. You extract the items one by one from the array. Be careful, you can only extract all the items in that array. You can't extract one like this, and you have to say which one you want, right? So the number of variables on the left-hand side must be equal to the number of items in that container. Then you can extract them. And so that's how unpacking works. And that's what we want to do, because there's a way to get the index of an array by doing unpacking. So naively, what we did before was for index. No, what we did before was for number, right? We did for number in, what is it called, my list or something? Number in my list. And what we now want, we want to now extract index and number in my list, and then print, see what we have, print the index. Now, if I do it this way, I get an error. So the error code here in pink below, let's just check the last line of that error message. And you can see type error cannot unpack. So I only highlight that word unpack here. The last line here in the error message contains the keyword unpack. So it's an unpacking problem. Why is it? And you remember, we want to have two things, but if you go through the items in a list, you only get the number. So you need to have a way to create that index in addition to be able to extract two things for the iteration. And it's very easy to do. And now this is then the proper Pythonic way to do it. It's for index, comma, number in. And instead of just giving the array, you use a function called enumerate. Enumerate, it highlights in green if you spell it properly, and then use parentheses to call the array that you are interested in. So it was called mylist. Have a look at this piece of code followed by colon and indentation as usual. So this is the way to unpack, not only to get that number from the array, but also its index. And you just use it in that way, enumerate of my list, and then you have two things. It will create tuples. And from the tuple, like we did above, you can create two items, which is first the index followed by the number. And then we can try print index. And here's our index, 0, 1, 2, 3, 4. And of course, next to the index, you can also print the number, and index 0 is associated with number 1, all the way down index 4 with 5, 5, 5, 5, 5. And then everything applies as before. You have the index, you have the number, and you can do anything with that number, like number squared or whatever you like to do. And there you have the, and if you don't like the way this is formatted, you remember I'll show you one that I didn't show in the introduction to the print function. You define a separator, which is one of those special things with the backslash, and it's \t, which is the tab operator. So if you separate them with tabs instead of a single space, then you have them more nicely aligned. And you can see that's probably what you want. You have the indices, the first column, followed by the number, the actual content of the array, followed by whatever you did with the array, in this case, squaring it. And if you think you don't want the index, but you want the position, like 1, 2, 3, 4, 5, of course, that you can do. You just add 1 to the index, and then you say the first is 1, and the second is 2, 2, and the third is 3, 3, 3, and so on. And yeah, that's up to you then. And remember, of course, now we're dealing with abstract numbers. The numbers here and what you do with it later will be data points, or like quantitative measurements, or brightness in an image, or so, something that you may want to analyze. And so analysis here, just squaring it, is not big of an analysis, but whatever you want to do, this is the way to do it. And of course, you can then also collect that in variables and so on. Okay, so that was nested arrays, and now the for loop. And we saw how to loop through a list in this case. And you can also loop through a nested list, but we're not going to do that because I want to go sort of a step higher. We have this other nested type of list, namely the one that is much more relevant for data science. And that is not the Python list, but is the Numpy array. Now, until now, I have always created my list, tuple, string, and so on using just by typing it in, right? So 1, 2, 3, and so on. And so, of course, typically we don't want to type things, individual items of an array. So let's see how we can create Numpy arrays in a data handling type of way. This means also we don't want to just make 1, 2, but we want to do any number that we can come up with. Any number and any type of nesting. So in order to do so, we need to import a little bit of Numpy functionality. So let's have a look at Numpy functionality. In Numpy, we often deal with random numbers. So rather than taking 1, 2, 3, sort of ascending integers, you can also do that. There's also ways to do that, but I'll show you one that deals with random numbers, because that's what we actually do in machine learning. We create data sets that are similar to our data set in terms of how they are arranged, but containing just random numbers, means there's nothing to find. And then we compare whether our data actually have useful information to extract. So for this, we take random numbers and we import the generators of random numbers from a library called numpy.random. And in this case, I want to import a function which is called uniform. That is, import the function to create uniformly distributed random numbers. So I do that only once, and then the function uniform is there, then I can use it. So, and now I don't call it my list, but I call it my data. So we're getting sort of into that feeling of dealing with numbers because they are measurements. So we use the function called uniform. And the way to deal with uniform, you can check it with, that's Shift Tab. You press the Shift key on your keyboard and then the Tab key, and then you get the information about how to use that function. And it says uniform, you give the lower boundary, you give the upper or high boundary, and then you say the size. Uniform means over a certain interval, which you can specify. That's why low and high. So within a certain interval, you can create a certain amount of numbers. So as an example, you can see without specification, it's called 0 and 1. So let's just do that explicitly. We want numbers between 0 and 1. And how many numbers? I don't know, maybe 5 numbers. And then we can do that. And we call my data. And we can see the 5 numbers that we got. Don't know if you noticed that it says somewhere, samples are uniformly distributed. So every number with equal probability over the half open interval, low to high. So half open means a 0 is included. So there is a probability to get a 0 as well. It's very small, but you could get a 0. You will not get the 1. I mean, the mathematical one, 1.000000, you will not get it. It's not included. But 0.9999999 and so on, yes, included. So within that interval, and you can see numbers are, the first one 0.988 and so on, and there's one 0.54. So that's what it looks like. If I do it again, if I execute that cell again, I get different numbers. So every time I do that, or if you want, I can also copy that code here. And then we can see them below each other. So first call gave me 0.73 in the first number, and the second call gave me 0.80. So it's just randomly mixed. So that's how you create sort of surrogate data or sample data of a specific size. Okay, now we have a couple of numbers. Now we want to iterate through this set of numbers. It's a Numpy array, but doesn't matter. Python convention is the exact same as it is with list or tuple. So let's do that for number in my, what is it called? My data, for number in my data, colon, new line indentation. Let's just check, print number, execute the code, and there are the most recently generated numbers. So you can see those numbers one below the other. And of course, you can do what you want with them. If you think those numbers should be between 0 and 100, then you just times it by 100, and then you have 80, 60, 85. If there's percentages, for example, here you see 80% instead of 0.8, and so on. So everything that we did before with list works also with Numpy arrays. Okay, move a level higher. So now we want to make a 2-dimensional array. So now we think, yeah, a linear line of numbers is not what we want. Typically in data science, we deal with rows, samples, and columns. Right? So we have a 2-dimensional matrix which contains everything that we have, and we can get that, of course, in Numpy as well. So let's do it, but let's do it in good practice, namely to assign it to parameter names rather than using the exact numbers that we want to specify, like we just specified 5 numbers. It's not very good practice. So let's specify rows and columns. And just as an example, 10 rows of 2 columns, meaning we have 10 samples recorded and maybe 2 different ways of measuring things. So we get blood samples, and we have measured the glucagon and the insulin amount quantitatively. with some method, and then the first column gives you the 1, the glucagon, and the second gives you the insulin, and then we have done that for 10 people. So we have 10 by 2 matrix, and we want to order them such that the samples go in the row and the different types of measurements in the columns. So that's the most widely used convention in data science, at least as Numpy and pandas and scikit-learn, so all the tools that we are going to use are concerned. So now we create new data for some data. Now it's new data, and we now say uniform. We specify maybe the same boundaries or whatever you like, and as a number of numbers that you want to have, you now use a tuple. So you specify rows and you specify columns, and the convention is first the rows and then the columns. I think that goes for many programming languages. Okay, now we can take a look. New data, execute the code, and here is the result. So we get an array, and the name array tells you it's a Numpy array. It's in square brackets. You notice maybe 2 pairs of square brackets. So we have, well, 2 levels of square brackets. We have the inner level and we have the outer level of square brackets. So that's why equivalent to the nested list that we did at the very beginning of today's session. And nevertheless, it's organized in rows and columns, and we have the specification of rows and columns, which reminds us of a 2-dimensional matrix in general. So that's how you typically have. You might, in data science, you then have the names of the measurements at the top, but we'll come to that later. So this is how we create a 2-dimensional matrix or a nested array with this kind of structure. Now there's this peculiarity which I mentioned before. Now we want to index the Numpy array. So it's called new data. Array is called new data. How do you index it? Well, let's try. What do you get when you ask for index 0? Think, what do you expect? Now I execute the code. You get the first row. Right, the first row here, you can see the first row is this, and it's the first item like we saw before in the nested list. So that's what we get, and then second and so on. Number 1 will be the next, and the last one will be -1 will be the last. So just everything the same as with list. Now maybe just a second, maybe not quite the same as with the list is now to referring to a number within that row. So that row has 2 numbers, and this you can get by comma within the same square brackets. So you don't need a second pair of brackets, but you put just the first is the number 0.09, so the left one. And if you say -1, 1 now, we did that before with that number 8, so that last number of that array would be -1, 1, because we have 2 columns, index 0 and 1. So that's the way of indexing items in a Numpy array, in this case, 2-dimensional array. Okay, now we understand everything. Now we can, of course, use our for loop and go through it, right? So let's go through it. And you remember, for loop, for extracts all the inner items. And now if the item is a row, like we just saw it, we had the row by row itemization with the first index. So we can also call the variable row for row in this array, which is new data, for row in a colon indentation. What do we want to do? We'll just print it, print the row, execute the code, and you will see the whole array, of course, because in every line it will print 2 numbers, and then it will do it as often as it finds a new item. When the last item is found, the code just finishes by itself. So now we go through that data set, two-dimensional NumPy array, row by row, and we access the elements. If you want to see a single element, of course, you can do that. You can just replace row with row 0, right? That will be the left number, and then you have just the left number. If you replace it with 1, you have the right number individually. Okay, let's just have both. And of course, as before, having the numbers, you can operate on them. The nice thing about NumPy arrays is that any operation that you do on such a row of numbers will be applied individually to every member. So it doesn't work with lists. So that's why iterating through nested lists is sort of tedious and you don't really want to do it. But in NumPy arrays, yes, you can do it. Namely, you can just copy and paste the code here. Here's my code. Instead of row, I can now have let's not do the square. We did that before. Let's do 1/2. And let's get the square root, right? So now in every line, you get 2 numbers. So because the square root was taken of each of the numbers in the line, that's the index 0, index 1, and then you have all the possible square roots by this simple piece of code very elegantly. Just one operation applies to each number and you get them down, you can see one by one. And of course, you can also do higher level operations. And just one of the things, maybe something that's now becoming much more relevant rather than printing the row. It's not very interesting, but something that you might want to do, you might operate, right? If you have the square root or whatever analysis you do of your numbers, and then maybe because you have 2 numbers, you want to see, well, maybe I want to see the average or the difference or whatever. You can try to do that. And one thing is you can do something like the mean. Little bit careful. If I execute the code, I get an error because mean of that NumPy array is not defined. So I need to import it. If it's not defined, of course it exists, but you need to remember this is the thing about NumPy arrays functionality. You import it from NumPy. So from NumPy, import mean, then we have the mean. And if we then execute the code, then we get it. And of course, we can also print it. Just put print around the means. And then we have for each row, print the mean of the row. And square root. So I took the square root of the row for each number individually, and then I got the mean of the square roots of that row. And I have all of the possibilities for every row in that NumPy array. And that's how you can successively then build up in complexity. And not that it's a very good practice, but maybe you find it annoying that the numbers are so ugly with so many digits. If you want to actually have it a little bit more nicely formatted, what you can use is a function that is rounding numbers, so giving you only so and so many digits that you can specify. It's called a round. So round that exists in Python, that would just round like list numbers if they are floating point numbers. Array round is the a round is the corresponding function for NumPy arrays. So you import a round, and then instead of printing the means as we did it, you can, I'll just try, see if you can follow me. I can just put a round around it, a round that number that we have here. And before you do that, specify that you want to see 2 digits. And if we do that, the result looks a little bit nicer. So that's just for cosmetics or for beauty, if you like. or 3 numbers, whatever number of digits you want to have. You specify that as a second argument of function a round. So that already goes into something that is very widely used in data science. Okay, that's basically it. You saw it, nested arrays. Comment, you can nest as many levels as you like. So we had a list of lists, but you can have lists of lists of lists, or tuples of lists of tuples. If you like, you can sort of mix them as you like and as many levels of depth in that nesting as you wish. Typically, NumPy arrays will deal with rows and columns. And there are occasions, and we will come to in the machine learning part C, where we want to have higher dimensional arrays. And the reason is that we have multiple such matrices and we want to stack them, right? If you think of this being the samples from one part of the population, maybe you have another part of the population where you have similar measurements made, and then you want to stack them all one on top of the other, then you would have a 3-dimensional array where each element or each layer is a 2-dimensional NumPy array like the one that we have had here. And it's very straightforward. Indexing and iterating, very straightforward once you understand this basic way. Difficult? No. Right. So just as a last thing, I think the lesson here is not too long or too much to do. Please have a look at it. I put to the contents of 2 weeks ago to the lesson 2 also a chapter on associative arrays, so the so-called dictionaries. And if you have a little bit of extra time, have a look at how dictionaries work. It's actually useful preparation before we go. Our next lesson will be introduction to pandas data frames, which is a funny way of using a dictionary as an associative array, if you like, in specifically designed for data science, or some comfortable functionality around it for use in data science. And enough of that. The only thing that, because we have a few minutes left to 3 o'clock, I just want to show you our first plot. So before we go then and do actual data science, and I guess you will expect that we will have some plotting to do, and there will be loads of plots when we come to the machine learning part. So let's have a very simple glance at plotting in Python. And what we'll do, we use a library called matplotlib, matplotlib, so it's the matrix plotting library or something like that. And then pyplot, pyplot, that sub-library, and from there we take all the functionality for this course. And I think that covers the majority of applications that you will find. I should mention there are specific libraries like Seaborn and others, maybe more interactive with JavaScript interfacing and more complicated thing. They're quite easy to use once you know the basics of how to work with matplotlib. Everything sort of builds on matplotlib. So this is the thing that you need to know. So like before, we import something, and let's just do one final example, and that's it. Just import plot. It's not the way how we are going to work, but just for ease, that to have something to show. So we import a function called plot. Let's just do that. So now we have that function imported, and let's plot our data set. What do we have? We have new data, right? Go back. What was it called? Where's our new data? Okay, so let's plot new data. And the way to do is, of course, call the function, which is plot, and then specify that you want to see new data. But if you remember, new data is actually 2 columns of data. So it's the first column and the second column. How do we plot just one column? Now let's see the indexing Maybe I do that first. Let's see the indexing of Numpy arrays again. So the first column was not called 0, but it was all items in the first column. So all items in Python colon in the first column has index 0 as usual, and by comma separated, we do rows, comma, column. So all items, all rows, all samples, if you like, in the first column with index 0. And that gives us, oops, as you can see, something with square brackets like a list. So it's a Numpy array, but like a list in square brackets, separated by commas. And these are the 10 numbers. So if this is what we want to plot, then we can just do the same thing in the plot here. So all comma 0. If we execute the code, okay, let me find my mouse cursor, then go down. I make it slightly smaller so we can see both the cell that created it, which is here. So I said plot new data, all rows of the first column, and then you get some plot. So by default, you can see there's a line between the points, and the axes are sort of estimated from the numbers that you put in by default. You can, of course, specify them, but we'll do that later. And then just a bit of functionality here. This strange line that gives you details about how matplotlib operates. If you don't want to see it, put a semicolon at the end of that line, execute the code, and it's gone. So that suppresses this kind of output. That's quite useful, because if you're not looking at it to analyze it, maybe you don't really need to see it. So that's gone now. Let's just have a couple of features. I take that same code, copy it over here, and then we can have many keyword arguments. You remember keyword arguments? In the print function, we use the sep argument to specify how our items separated. And there's loads of keyword arguments for matplotlib. If you Google it or just find it in the documentation, you will have a look at this individually, all separated by comma. And the first thing is the color. So you can specify color. I think you can write the whole word color, but in short, C. C stands for color. And then you can refer to typical or widely used colors with just a single letter abbreviation. So that was previously was blue. So if we specify red, it will just use the red color. So that's how you change the color of that line that connects the individual points. If you think, well, actually the values that I had, my data points, so to speak, 0, 1, 2, 3, with the index here from 0 to 9, all values between 0 and 1. You remember we took them from between 0 and 1. And you have some that are below 0.1 and one that is about 0.7 randomly. If you want to see those points, maybe you want to not see the lines, but the actual points, you can specify the marker, which is by default nothing, but you can specify something like in quotes, I don't know, to have the star, like for multiplication, that multiplication sign. If you put that as a marker, you will actually see something. If you can even have the marker colors, the markers in a different color. So now we have markers there, but you don't really see them because they're the same color. Specify the marker color is MEC, marker edge color. And what do we want to have that? Maybe we do that black. If that's K, K is for black. Now we have the markers in black, so you can actually see them where they are in this, behind this red line. And if you think they are too small, you can also increase them. Use another keyword argument, which is marker, I think, size without an underscore. And if you set that to 1, then they are so small that you can't see them. But if you set them to 30, then you can actually see them. Okay, that's enough for today. Now you saw we can handle NumPy arrays. We can iterate through NumPy arrays. We can extract information. And once we have, say, analysis of data, like in this case here, say this was the result of the analysis, we are then able to plot the result and make a graph. And I don't know, there's a very large number of keywords with which you can specify just about everything around the plot to get to figures that you can submit for with your paper to a journal. Okay, that's it for today. So with this little plotting introduction, we'll do much more plotting once we have data and once we do machine learning. Thanks very much for watching. A link to video will be included in the web page. And please make sure you have all your assignments ready before we then enter data handling in 2 weeks' time. Bye. And for those who want, I can take a look at the chat function. No questions in the chat function. Okay, so see you next time.